Hi guys, my name is Hrithik, and for this episode we have two professors, Professor Marcel Turcotte and Professor Guy-Vincent Jourdan, and I met them in my first year of studies here at uOttawa, where they taught Introduction to Computing 2, and I thought they were both phenomenal professors, and I loved their lectures and I thought they were both very interesting, and they hosted their review sessions together, and I thought they both had really great chemistry, and I thought it was really inspiring, so I thought, how about we bring them onto the show? And I'm really excited that they're here today. So we're gonna sit down with them, discuss what they're both researching right now. Professor Marcel Turcotte is researching Machine Learning and BioInformatics, and Professor Jourdan is researching Cybersecurity and Cybercrime. So let's get on with it. All right, thank you for coming in today. It's really my pleasure to have you guys on this show. I had you guys both in my first year, or I had Professor Jourdan in my first year,
yeah,
and you were there for the review session, so that's where I got to know you.
Okay.
So I really liked the way you guys teach, and I thought you guys were inspiring.
Inspiring.
So,
well,
thank you so much for coming.
Thank you for
today.
yes.
Yes. And the first question I want to ask is, tell me a little bit about yourself. So, what you do at Ottawa, what courses you teach, what your education is, and what you're currently researching. So, a quick introduction.
All right. Okay, I'll start.
Yes.
Okay, so I've been in Ottawa for 19 years. I came from London, England, where I was doing research in bioinformatics, which is my topic. I still do that. I do bioinformatics and machine learning. In terms of education, I did all my degrees at the University of Montreal. Yeah, that's about it.
Right. Well, I don't come from London, but I come from Paris. So I'm French, and I've done my studies up to my PhD in France, in Rennes, for the PhD, and the equivalent of master in Paris. And before I was in the South, Montpellier. And I came to Ottawa in 1997. To the city of Ottawa, but not to the University of Ottawa. I came here to work in a small startup. And I worked in that startup for many years. And I left the startup in 2004 to join the University of Ottawa, where, so I teach, I met you, I teach programming, first year Java, and I also teach I've taught security, I've taught web programming, and I teach also in engineering management.
Okay, so how did you guys choose to do software engineering / computer science? What do you guys like about this field, and why did you choose to do research?
Okay, so I was introduced to computer science in a strange way. At the time, I'm slightly older than you are, and at the time, we didn't have really computer science at school, and even at the university, we didn't have computer science in first year at all. And in second year, I was in mathematics, and we had our introduction to computer science. And the prof who was teaching this introduction to computer science, I don't know how they chose that guy, was Jean-Marie Bouet, very nice guy. And this guy was a theoretical computer scientist, could not be least interested in the usual computer science introduction type of course. So his introduction to computer science was formal languages and automata. So that's how I learned about computer science. Now, I loved it. I thought it was the best thing. And so that's why I switched to computer science, because I thought that was what computer science was. So I had a bit of a surprise after that. But I actually really enjoyed it. I liked it. I liked the the formal aspect, of course, the theoretical aspect, but also the practical aspect, programming. I started to program in my third year. I didn't program before, and I really enjoyed it. And what drew me to that really is, this endless capability. You can do whatever you want. There is no, everything is possible, basically. You just code it. And to me, there's been it's still something that attracts me, this ability to do whatever you want in software. And then I started to be more and more interested in more practical things, like network, running my own server. I had my own internet server in 1997, I think. Was my own domain name, so not a big deal nowadays, but at the time, only to have a domain name was $100 US. Wow. So you really had to want it. And so, yeah, that's...
So for me, I was heading to maybe aerospace engineering or electrical engineering, something like that. And I had never programmed before. So I'm from Quebec, so we have CEGEP. And after doing natural sciences, I said, why don't I do a year in this computer science program? And I just felt in love. I guess the fact that I had like perfect marks was also helping. But for me, what I really enjoyed about it was the idea that when you're programming, when you're coding, it's like a little bit an out-of-body experience for me. It's your own idea. You've put it on, at the time it was paper, but you've coded this thing, and now the CPU is executing this at an amazing speed. For my research, I use very big computers, some terabytes of RAM, thousands of CPUs. And so this whole idea that you had an idea, you coded it, and now you run this on hundreds of CPUs, and it's your thought, it's your idea, and it's now automated, and it's computing results. That was the thing really that made it for me. And the same thing now, I do a lot of machine learning, and I'm amazed when you program something, and then the computer, the program produces a result, and you're like, oh my God, I never thought of this. And just out of the blue, you have these amazing results that you did not envisage at the start. So for me, that's really something I enjoy. And I enjoy coding a lot, yeah.
Professor Jourdan, you said that you had started your own startup, right? And but after that, you started doing research, right?
That's right. I did not start my own startup. I joined a very small startup that was started based on some research I had done as a PhD student.
Yes. So why did you choose to, I guess, leave the startup and then pursue your own research? What was the thought process behind that decision?
It's just, the startup world is fantastic. I love it. If I was not doing what I'm doing, I would definitely be back there. But it's very demanding. So sometimes you need to change. And I had reached a point. I was the CEO of the company. We had about 40 employees. It was, it's a lot of sales, a lot of support, a lot of development, not a lot of technical development at that point. And I had it. It was time to change. So I left the company and I started looking around for something else to do. And then an opportunity came up at the University of Ottawa. And growing up, that's what I wanted to do. I wanted to be a professor. I wanted to do research. And so when the opportunity came up here, I said, well, it's never too late. Let's try. And I guess I liked it because I have stick around for for a long time now.
It's good that you pursued your dreams.
Yes.
Yeah.
It's never too late.
It's never too late, yeah. You said that, okay, I don't know if I'm pronouncing your last name correct. Is it Professor Turcotte or
Turcotte.
Turcotte? Okay, Professor Turcotte. You said that when you're doing your or running your program, right? It's across multiple. I'm guessing it's across multiple machines and.
Sometimes.
So this is kind of off topic, but Apple released their new Mac Pro. Right?
Are you going to buy one?
No,
Well,
no.
why not? just the monitor looks, you know.
Yeah, the monitor is cool, and you can grate cheese on the Mac Pro.
But I guess, what are your thoughts about like the Mac Pro is it's like a beast of a machine, right? It has high RAM, high storage, and such amazing processing power, right?
Yeah.
So what is your opinion on machines like this existing at a cheaper price point in the future?
I mean, in terms of the Mac Pro, one of the drawbacks for me is that I'm doing machine learning. And when you're doing deep learning, NVIDIA has an edge because of the platforms like TensorFlow, etc., are running much more smoothly on these GPUs. And there's a big fight between NVIDIA and Apple. So for me, I cannot really use so much the Apple machines for my research. But the Compute Canada, so in Canada, we have this great environment where we can do research, and there's literally thousands of CPUs available. But I think that everybody can now do pretty sophisticated computation, even on laptops where you get these NVIDIA cards. They're amazing. It just flies. It's very rapid. I mean, in the old days, I used to hack a lot, and I was system administrator during my PhD to get a little bit more money and all that. And I'm very tempted to build a server of my own, but I sort of refrain myself from doing that. I have to focus on my research, my teaching. But I think nowadays it's very easy to just buy a chassis. You put some cards. It's something really fun. It's something Linux is so easy now to install, to work with. If I had a little bit of time, I would hack these things.
So, what sort of research do you do?
I start?
Yeah.
Okay, so it's called bioinformatics.
Okay.
So really what it is it's a lot about analyzing genomic data, so your DNA, trying to understand the genomes in its normal state or abnormal state, disease, trying to understand gene regulation. And so I approach the problems in two ways. One way is algorithmic data structure, the other way is more machine learning. So in one case, I'm interested in algorithms that will run in linear time using linear amount of memory, because these genomes are very big. Your DNA is 3.2 billion letters long. So we cannot afford to do quadratic. It has to be linear. And the machine learning is a mixture of different things. It's deep learning, but it's also some exotic thing called inductive logic programming.
Okay, so for me, when I first came to the university, based on my PhD, I was interested in modeling of application testing, verification. So perhaps more on the more mathematical aspects. And but I've changed over the years, and I always had an interest in security. I was curious about it very early on, and then I had a practical interest in it, because in my own company I wanted to make sure that the program, that we had, the application, was secure, because we were handling students' data basically. So I had this practical interest in software security, and we have some colleagues here, in particular Carlisle Adams. Professor Adams he does research in security, and we started to work together. And so my interest grew around security in terms of research, and then I started to work with IBM. And so right now I can say that this is 100%, or almost 100% security in general, software security in general, with a focus of late in cybercrime, so prevention of cybercrime, protection, analysis of cybercrime in general.
Okay, perfect. So I will ask you a follow-up question, and so I don't know too much about cybersecurity, but is it like encryption of data or not at all?
So no, encryption and cryptography in general is a field on its own, and it is a necessary tool. You cannot really be involved in security if you don't understand the tool. But you don't need to be a specialist of that tool to do security. So I don't do crypto. Carlisle Adam does, and we use crypto, as part of the design of a secure system, of course. But that's not necessarily what you should look at when you look at the field of software security in general.
So currently, you said cybercrime, right? So
that's right. Yeah.
Is that is that like stealing of someone else's data?
For example, yeah. So that's when software security, let's say this is about writing secure code. Cybercrime may not involve any insecure code at all. It may simply be someone phishing someone else for their data, and there is no vulnerability beside a user. So cybercrime may use vulnerabilities in software, but doesn't have to. And but it's still something that is happening. There is a technical aspect to cybercrime. For example, is that site a phishing site? Is it, is that software malicious in any way? And so there's a technical question to answer here, and a lot of technical constraints, like find the site, decide reliably that this is a bad site, do it fast enough that you can do it at scale. So we are interested in something that can be used at an industrial level. So we want to protect the world, not one person. So you can, if you have the perfect solution that requires a few seconds to decide whether a site is okay or not, that is of no interest to us, because obviously that's not fast enough for 100 millions of access per hour. So it has to be. It's a bit similar to Marcel. It has to be very fast if it has to be if it's going to be useful. So that's the kind of thing we do. Yeah.
Well, questions for you. So you said bioinformatics is, if you look at the DNA, right, which is, you said, billions of...
Yeah, 3.2 billion letters long.
Wow. So do you use, I guess you definitely have, maybe, what I'm thinking is, so in this field you get data of patients with different diseases, and then you would apply maybe machine learning onto it to see if your model can classify patients.
Yeah, now we start to have data on patients because the technology for reading DNA is getting to a point where it's feasible. Okay. Because the first the sequencing of the first genome took something like 15 years, and it cost $15 billion to do the first one.
Wow.
And now the price of the technology has dropped considerably, and now we can do it below $1,000. And I think that most people, if their child had a disease and you think that having the sequence, the DNA sequence of the child would help producing a diagnosis, you would just fork this $1,000 easily to have a definite answer. So yes, we do analyze entire genomes of patient cancer genomes. Now we can do comparative studies of what are the differences between the various types of cancers. We're using all sorts of data types. So there's all sorts of technologies that allows to measure the level of expression of genes, and then we're going to compare the different type of cancers. So you would like to be able to, when someone is coming in, to be able to precisely tell what is the subtype of cancer that the person has. There's also a huge opportunity for pharmaceutical companies where some drugs have secondary effects. And to develop a drug takes something like 8 to 10 years to go through the process. It costs about $800 million to develop a drug. And sometimes at the end of the process, you realize that there's all these side effects. So now we have the opportunity to be able to identify very precisely the subgroups for which there are secondary effects, and then repurpose drugs that were put on the shelf because they had too many secondary effects. And now we can say, for these folks, the drug will not have these secondary effects. So those are that's one kind of problem we're working on. But I tend to work with colleagues that are working on organisms that are bizarre. I have a colleague at the University of Montreal that works on a phenomenal organism. It's a unicellular organism that lives in the sea, has all sorts of quirkiness. In particular, one of them is that the genes are encrypted. And we can talk about that at some point. You might be interested in that. So we try to develop algorithms that will produce new knowledge, that will enable scientists to understand how these organisms are able to function.
Yeah, so this is a question to both of you. So if a student wants to work with you guys on one of your research projects, right? Mm-hmm. What is the best way to get involved with you?
I think if I may start, I think and that's more of a general advice even, not just, but we are flooded with generic requests from students from here and from all over the world. People are just sending hundreds of requests that are completely generic just to see if someone bites. Don't do that. It's just a waste of everybody's time. Just don't do it. So if you are interested in working with Marcel or with me or with any of our colleagues, what you should do is look at what it is we are doing and tell us, approach us with project or with a question or with something that shows some interest. Because we are going to be super happy to talk to you about what it is we do if we think you care. And so
we're actually difficult to stop when
when we start
we can talk forever.
That's very true. That's very true. It's just you have to show that you would be interested in listening, and then once that starts, then there are all kinds of opportunities. You can start even first year students, second year student can start doing some projects that are related to our research. I have students that are doing that, and of course, the more advanced you are, and the easier it is to be involved in this project. And
there's the undergraduate research opportunities, so you could be paid to do an internship in our labs. So it depends. There's several entry levels, so it's very easy to.
There is a fourth year project, of course, where you can approach a prof for that. But I think in general, if you are really truly interested, so for me it's security, if you are truly interested in security and you show it to me, I would want you to work with me. I'll definitely find something for you to do. And I'm probably not the only one interested in what I'm doing. So all of my colleagues would do the same. And the reason why they are not open is because you don't show clearly interest. You are just interested in the idea of getting a job or getting, but that's, we have too many requests for that, and we cannot just accommodate them. But interest in the topic, that is something we can work with. Yeah.
So the next question I have is, what do you see for the future of the field that you're researching? What is like maybe the next 5 years look like in your respective fields?
I mean, in terms of machine learning, the unsupervised part of it is should get much more attention because it's believed to be a key for accessing general AI capability. So there should be a lot more emphasis on this unsupervised learning. I think in terms of the genomics aspect, we should expect that we could get a lot of diagnosis, or even that you can have an app that will tell you, given your DNA, you should be exercising more, you should be eating this, avoid eating that. So there should be a lot more of these information that are based on your metabolites, your genes, your genome, and all that in the next few years.
Yeah, so in terms of, so if my research is in cybersecurity, I think what we can expect is, well, in terms of research, what I hope the focus is going to be on is, a lot more usable solutions, and we are focusing on what I call zero delay protection. So that's where you can protect the user before there's a victim, because right now a lot of work is done based on a report. Someone got hacked. What can we do? What happened? How can we prevent that from happening again? It's more interesting to prevent it from happening in the first place. So I think that's a direction. And I think the maturity also of the field, understanding more and more that this is not necessarily just a technical field, and that there is only so much you can do focusing on technical aspects. And so there is a lot of work to be done outside the purely technical aspects of that, without completely overlooking it. I mean, this is a technical problem, but the solution is definitely going to be a lot more general than that. So I think that is what is going to happen in the next few years. That we will go there, maybe, or closer.
That's good. So what mostly we do is we ask if students can contact you, right? So, and then we ask if we can share your research paper, so like the links to your research in the description.
Yeah.
Yeah, I mean, that is just a question like that. Yeah, of course.
This is like, sorry, there was a cut.
Yeah.
Yeah. Okay.
Yes, of course. As I said, students should contact us. They do. My advice is, probably if I did not answer to you when you contacted me, it's because you sent something that I felt was generic. Yes. I probably didn't even open your message.
Right. So be as specific and as I guess interested as possible.
Exactly.
Show that you've done you worked on like maybe a project on your spare time. Show that how and why you're interested in this field and what you can contribute to their research.
That's true.
Yeah. I mean, we list our publications on our websites. They're easy to find. So if you read even the introduction of some of our papers and you say, I read your paper on this particular subject, that was so cool, I'm interested in working on that. Do you take students? Those are the kind of messages that we follow up with, basically.
Okay. Thank you so much for coming today and
Pleasure.
taking some time out of your busy schedules.
Thank you for having us. That's
Yeah.
great.
Okay. Thank you
Congrats
so
on
much.
that, by the way.
Yeah.
A very interesting project.
Alright guys, that's it for this video. I hope you guys enjoyed learning about what Professor Turcotte and Professor Jourdan are researching, and I hope you guys are going to get involved with some of your own research soon. So if you like this video and you've been liking this series, please like, subscribe, and hit that bell icon so you can see the next couple of videos. That's it for this one. See ya!